First, we determine the value of t which corresponds to this point 4 comma 3. So here we consider x equal to 4. Replacing x by 4 into this equation, we get 4 equals 3t squared plus 1. Subtracting 1 from both sides, we get 3 equals 3t squared. And dividing both sides by 3, we get 1 equals t squared. Solving for t from this equation, we get two values of t, that is t equal to 1 or t equal to negative 1. So when t equals 1, we can substitute in both the parametric equations. That is, if we replace t by 1 into the equation for x, we get x equals 3 times of 1 square plus 1, and this equals 3 plus 1, which is 4. And let's also replace t by 1 into this equation, and when we do that, we get y equals 2 times of 1 cube plus 1, and this equals 1 cube is 1, 2 times 1 is 2 plus 1 is 3, so we get y equals 3. So therefore, when t equal to 1, the corresponding point is 4 comma 3. Now let's find the point when t equal to negative 1. So we have to replace t by negative 1 in both the equations. First, let's do in equation for x. And when you do that, we get 3 times of negative 1 square plus 1. And this equals negative 1 square is 1. 3 times 1 is 3. 3 plus 1 is 4. So we get x equal to 4. Now replace t by negative 1 in equation for y. And so we get y equals 2 times of negative 1 cube plus 1. And this equals negative 1 cube is negative 1. 2 times negative 1 is negative 2 plus 1. And this gives negative 1. So y equals negative 1 when t equal to negative 1. And therefore the point is 4 comma negative 1 when t equals negative 1. So let's put the points when t equal to 1 and t equal to negative 1. When t equals 1, the point is 4 comma 3. When t equals negative 1, the point is 4 comma negative 1. And we now need a slope so that we can find the equation of the tangent line with a positive slope. So first, let's determine the slope of this parametric equation. Let me copy the parametric equation. We have x equals 3t squared plus 1, and then y equals 2t cube plus 1. So for this parametric equation, the slope is given by this formula, that is dy by dx equals dy by dt over dx by dt. So let's find dy by dt and dx by dt and substitute into this equation. So we have y here. I'm finding dy by dt by differentiating both sides with respect to t. When we do that, we use this power rule to differentiate t cube. So it is 2 times of 3t squared. The derivative of 1 is 0. So you can just ignore that. And so this gives 6t squared. This is dy by dt. Now let's find dx by dt by finding the derivative of this expression with respect to t. So we have 3 times of the derivative of t square is 2t, and then the derivative of 1, which is constant in 0. So here we get 3 times 2t is 6t. This is dx by dt. Now let's substitute into this dy by dx. So we get dy by dx equals, we replace this dy by dt as 6t squared. So we get 6t squared divided by, replace this dx by dt by 6t. And so we put 60 here. We see that we can cancel the 6 and 6. And t squared divided by t is basically t power 1, or else it is just t. So we found that the slope of the curve or the slope of the tangent is t. Let's determine when it gives the positive slope. So when t equal to 1, we get the positive slope. This one is dy by dx. So if we plug in t equal to 1, the slope equals dy by dx when t equal to 1, and this equals replace this t by 1, we get the slope is 1, which is positive. So here the slope is positive when t equal to 1. And now let's substitute t equals -1. We get the slope, and this equals dy by dx when t equals -1. And this equals, we replace this t by -1, so it is -1. So we found that the slope is negative when t equal to -1. And so thus we have determined that we need the point as well as the slope so that we can find the equation of the tangent lines. So let's find the equation of the tangent line with the positive slope. Equation of tangent line with the positive slope. We already determined that the slope is positive only when t equal to 1. So we are using the condition t equal to 1, and that means we have to use the point 4 comma 3. So the point is 4 comma 3, and then the slope is positive 1. This means we can find the equation of the tangent line with the point and slope form, that is y minus y1 equals m is the slope times x minus x1. Here the point is x1, y1 is 4 comma 3. So therefore plugging it into this equation, we get y minus 3, and this equals slope is 1 times x minus x1 is 4. Let's simplify this. So we have y minus 3 equals x minus 4. Otherwise, adding 3 on both sides, we get y equals x minus 4 plus 3 is -1. So this is the equation of the tangent line with positive slope. Now let's find the equation of the tangent line with a negative slope. Here we should consider t equals -1, the corresponding point, and the slope. The point is 4 comma -1 when t equal to -1. So we use the point 4 comma -1, and the slope is -1. We use this when t equal to -1. So we see that slope is -1. Once again, we use the point slope form. That is y minus this one is x1, this is y1, y1, that is -1. This equals slope times x minus x1, which is 4. So this gives y plus 1 equals, let's distribute the -1. We get negative x plus 4, or otherwise adding x to both sides, we get y plus x, and this equals 4 minus 1 equals 3, or otherwise we can write this as x plus y equals 3. And so this is the equation of the tangent line with negative slope. Otherwise we write this equation in slope intercept form, that is y equals negative x plus 3. Thus we have determined the equation of tangent line with positive slope, which is y equals x minus 1, and the equation of tangent line with a negative slope, which is y equals negative x plus 3.